All right, so first question we'll take a look at is finding the equation of a horizontal and a vertical line that goes through a special point. So in this case, the point is -4, 5. So what you can always do, you don't have to do it this way, but you can graph the point if that helps. So you've got my -4, 5. Oops. Okay, so there's our point. And we want to find an equation. Let's start with horizontal. So horizontal and vertical are both special cases. When you want to write the equation of a horizontal line, how does that start out? So it's not y equals mx plus b, because that would be if it was on a slant. It's we've done it before on the graphing calculator when we put like a horizontal line at a point. We usually, it has just one letter on the left and then a number on the right. Do you remember what the letter is that goes on the left? Not sure? How about for vertical? So do you remember for vertical, what letter goes on the left? It's one we can't do on the calculator. So it's the letter we can't change on the left-hand side. We can never have this letter on the left on the calculator. So y is the letter we can have on the left. So if you look at the calculator, normally you always have the y on the left, and you can't change that. So y we always have on the left. So let's go back to that one. If you do y equals a number, what kind of line would that be? So if you do like y equals 10, would it be a horizontal line or a vertical line? Horizontal. So y equals, because if you type in like y equals 8 and then hit graph, it's a horizontal line at the number 8. So when we want to find the equation of horizontal line, we're going to start out y equals, and then we have to pick the number we want it to go through. In this case, we want our horizontal line to go through what value? Yeah, we want the horizontal line to go through 5. So what would be the equation of the line that goes like I just drew it right there? Yeah, y equals 5. So that's the horizontal. All right, and now we want the vertical.
Yeah, I heard this.
So what kind of, what letter would be on the left for vertical?
X.
Yep, so it would be x equals. And then what value do we want our vertical line to go through? -4. Yep, so it would be right there. So that's how you find the equation of a horizontal and vertical line. All right, let's take a look at this one. So this one is, again, about finding the equation of a line. It could be horizontal or vertical, but it won't. This one is going to be different. It's going to be more like y equals mx plus b. And they give us these two pieces of information. Now, when you're given something like that, we normally write this information a little differently, but these two numbers are basically giving you a what on the line? They're giving you so like, what does this information tell you? F of 3 equals 8.
Wait a minute. X.
So think about like when you have this number, the 3 would be what kind of value in a coordinate? What would it be? That's the x. So this is a number you would be plugging into the f function, And then when you do that, you would get an answer. What do we usually call the answer that you get when you plug something into the formula?
Like f of x.
So yeah, f of x, so the x is what you plug, the number you plug into the formula, and the answer that you get, you can call it the f of x or the, think about if you're going to write it as a coordinate. You said the y value. So this is basically a coordinate. How would you write this information as a coordinate rather than writing it in f of x notation?
3, 8.
Yeah, it's really just the coordinate 3, 8. And how about the bottom one? 5, 12. Now, what's one thing that we need to figure out if we want the equation of the line?
Slope.
Yep, we need the slope. And the other thing we need to find the equation is the, well, let's say we want to do it in y equals mx plus b. We would need the slope and the y-intercept. If we were using like point slope, we could do it differently. Okay, so that's how our answer has to look when we're done. Okay, how would I find my slope?
Do the like y2 minus y1 over x2 minus y1.
Yeah, and if you plug those in, what would go in the top?
8 minus 12.
Okay, now just make sure you do it in the same order for the bottom.
3 minus 5.
3 minus 5. Okay, and 8 minus 12 is going to give me negative 4. And 3 minus 5? Negative 2. Alright, so that's going to give me a slope of 2. Okay, so we got the slope. And now, let's solve for the y-intercept. So, to solve for the y-intercept, I could use either one of these coordinates. One of them will be the x, one of them will be the y, and then I'm going to use 2 for the slope. So which coordinate do you want to use to find the y-intercept? 3 and 8? Okay. So what's the y value in that coordinate?
8.
8. So we're going to have 8 equals, what's our slope? 2. What's our x value? 3. And b, we don't know. So we have 8 equals 6 plus b. So that means b is going to equal 2. All right, not a great example because the slope and the y-intercept came out the same. That definitely doesn't have to happen. Now, how would you write your final answer using our slope and y-intercept? Yep. Again, just a coincidence that they came out the same. So there'll be some questions where you have either a coordinate or something in f of x notation, and you have to find the equation of the line, just like that. Okay, so in this one, we're going to find the equation of a line that's parallel to a given line and passing through a given point. Because we have a point and we're ultimately going to find something else, we're going to use a different formula than y equals mx plus b to try to do this. So if I want to have something that's parallel to that line, what's the first thing I need to know about the line that's in that box? Well, if two lines are parallel, what does that mean? Besides saying they don't cross. I don't want to know that. I'm thinking of something else.
But they're the
opposite. How do you describe the steepness of a line? What do you use to describe that? What concept describes how steep a line is? Like if you compared a line like this compared to a line like that, they would have different what?
X, Y.
So let's say these were actually like my graph. Let's say like, here's my XY axis. And let's say this line went like that, and that line went like, well, that's not the best. Let me fix it. Draw another one like that. So both of these lines have the same y-intercept. But what's different about them? The slope. So in order for two lines to be parallel, they would have to have the same slope. So what do we need to know about this line if we're going to find one that's parallel to it?
Project on. Oh wait, no, you said we don't want to put it in y equals mx.
Well, we got to figure something out about this line.
Yeah.
We have to know its what?
So,
Slope. So however you can figure out the slope, putting it in y equals mx plus b is one way to do it. We're going to do our final answer, we're not going to use that. But to get the slope, that's probably the easiest way to do it. So if you wanted to put this in y equals mx plus b, what would you have to do?
subtract the 4x and divide it all by 2.
Yeah, subtract the 4x and divide it all by 2. So if you subtracted the 4x, you'd have negative 4x. And then if you divide that by 2, you get?
You get y equals 2x plus 6.
So plus 6, yes, that's good. And what's the sign going to be on the x? Because remember, that's going to be on the other side.
Oh, negative.
Negative, so negative 2x. So now we should be able to figure out the slope of that line. What's the slope?
Negative 2.
Negative 2. And I want to write an equation of a line that's parallel to that. So my new line is going to have a slope of
Negative 2.
negative 2. So the new line has a slope of negative 2. And then what's the x value that it passes through?
6.
So the x value of the coordinate that it passes through.
Oh,
5. Yeah. And the y value of the coordinate?
2.
2. Do you remember the name of the other type of equation that we use? It's not slope-intercept, but it uses this piece of information and that piece of information. So what is this called? This part right here? Yeah, it's a point. And what is this? Your slope. So the other type of equation we can use is point slope. And that will be the easiest way this time to get the equation we're looking for. So point slope is y minus y1 equals m times x minus x1. And now we just fill in everything we're missing. So the y stays. And what's y1 in this case?
2.
2. And the slope?
Negative
2.
2.
And x1? 5. So if they're okay with you writing your answer in point slope form, you can leave it just like that. Now, let's go one more step and say they said to put it in y equals mx plus b. How would you get that in y equals mx plus b?
Distribute the 2.
Yep, so distribute, what are you distributing?
The negative 2.
Negative 2. And what would that give you when you distribute?
Negative 2 plus 10.
Negative 2.
Minus.
More we have to put before we get to the plus 10. Negative 2.
Oh,
X. So negative 2x. And then negative 2 times negative 5? Plus 10. So that's not in slope-intercept form yet. Now it's kind of halfway there. And what would be your last step?
Oh yeah, because you can just divide
Well, if you divide everything by 2, then you're going to end up with a 1/2 in front of the y.
So you add the 2.
So we're going to add the 2.
Oh, wait.
So negative 2x. And what would your y-intercept be? 12. So this is slope-intercept form. And then another form you sometimes see, and we kind of did a little bit of this today, is when you put everything on one side and you get it equal to 0. We don't do it as much with lines, we do it more with quadratics, but you can do it with a line. So if I wanted 0 on this side, I could write the answer as negative y minus 2x plus 12. That's a third way you can write the answer.
Would you, for the quiz, would you just want
So on the test, you're going to see a little bit of all of these. There will be some where you put it all on one side, and then there'll be some where you can write the answer like as y equals mx plus b. Yeah. Any question on any 3 of those? Okay, so that pretty much covers the line. Okay, so domain and range. So remember, with domain, there are 2 types of functions you have to be careful with. If you're dealing with a square root, you want to make sure you never plug in a value that causes you to take the square root of a negative. If you're dealing with a fraction and it has a variable in the bottom, you never want to plug in a number that could give you 0. So for the top one, does that fit either one of the cases I just said that you need to be careful with? Yeah, which one? The dividing by 0 or the square root?
square root?
Yeah, that's a square root. And what numbers could you pick for the domain so that the radicand never comes out negative?
Negative 2.
Negative 2 and?
Oh, infinity.
Yeah, negative 2 to infinity. Including negative 2 or not including?
Yeah.
Yes, you can include it. So everything from negative 2 and up. And now, let's see if we can do it without a graph. We'll do a graph for the next one. But if you plug numbers, any number you want between negative 2 and infinity in for x, what's the smallest answer that you could ever get?
0.
0. You can't get an answer smaller than 0. If you plug negative 2 in, you get negative 2 plus 2 is 0, and the square root of 0 is 0. So the smallest answer you'll ever get is 0. And what's the biggest answer you would ever get for y if you plug in numbers between negative 2 and infinity? Infinity, yeah. So that's the domain range.
I never really understood the difference between domain and range, but no.
Okay, yeah, so domain is the numbers that you're allowed to plug in. Range is the answers that you get out. That's the difference. So here, let's do domain. Is this a function where you need to be careful about what you plug in? Okay. Can you tell me what are you allowed to plug in here?
You can do anything but 0.
Okay, anything except 0. And do you remember how we write that as an interval?
You do negative, or 0, infinity, and then negative infinity equals 0.
So 0, comma, infinity. And what else?
Negative infinity, comma, 0.
Negative infinity, comma, 0. Okay, anything else you need?
The both would have close parentheses.
Both would have what symbol again?
The
Parenthesis. Yeah. So that means it's an open interval because you're not including the endpoints. I don't know if I've used that word specifically yet, but open interval means don't include the left endpoint, don't include the right endpoint. Anything else you need there?
Sure.
So that's an or. You can either pick a number lower than 0 or higher than 0. So the symbol we usually use for or looks kind of like a capital U. Okay, now let's think about the range. And it might be helpful to draw it so we can see what's going on there. So 8 divided by x. Well, we know we can't use 0. So that type of graph, that's a hyperbola because it has 2 curved branches. It's actually a hyperbola like on a 45-degree angle. Now, how high does it look like the graph is going? It is going to infinity. Because think about if you plugged in a number like very close to 0, like 0.01. If you take 8 and divide by 0.01 for x, look how high of a y value you get. And the smaller and smaller you make x, the bigger and bigger y gets. So it does go up to infinity. And how low do you think the graph goes? Say that again?
Infinity.
Well, infinity is a high value. Negative infinity would be the low value. Now, we know it goes up and down forever, but then the question is, does it hit everything in between? Well, think about what happens if x gets bigger and bigger and bigger and bigger. Let's say x is 10. If you have 8 and you divide by 10, what would that be as a decimal? 0.8. Now, if you have 8 and then you divide by 100, you get 0.08. If you have 8 divided by 5,000, you get 0.0016. How low can this number get if we keep making the denominator bigger and bigger and bigger? It'll get close to what number? Whatever reached 0. Will it ever reach the number 0? No, because no matter, even if you take 8 and divide by 1,000,000,000, it's still not going to be 0. So what's happening is the graph goes to the right. It's getting lower and lower and lower and lower, but it's never actually going to touch the axis. So the range here is every number except one value. 0. Yeah. Your graph will never hit 0, whether you head left or right. You'll never get a 0 no matter what you plug in for x. So the range is actually the same as the domain. It's all real numbers except 0. Okay, any questions on the domain and range?
So it was you don't divide by 0 and then you don't square it.
Correct. Yep, those are the two things. All right, so another topic we looked at this week was finding roots. So I have a cubic up here, 8x cubed minus 4x plus 6. And if we want to graph it to find the roots, what do we have to set it equal to? Right, we have to set it equal to 0. This one pretty much already has everything on one side, so we can just graph it the way it is. So let's graph that. Okay, so there's our equation. Let me just move it so we can see. And the first question says to find the number of solutions. So how many solutions does it look like that problem has? So what are we looking for graphically when we're solving that? We're looking for where the graph does what? Crosses the x-axis. Yep. So how many times does it look like it crosses? Just once. Yeah. And where does it look like it crosses? At what value? So you think it crosses like right about there? Negative 1. So we got to figure out if it is negative 1. We could actually just plug that in and check it and see if we get lucky. What's negative 1 cubed? Negative 1 times 8. So that's negative 8. And then what's negative 4 times negative 1? So that's negative 8 plus 4 plus 6. Close, but not quite. Negative 8 plus 4 plus 6 is not 0. So the answer is not negative 1, even though it looks like it. It's probably like 0.9 or negative 0.9 or something like that. So we got to check it. And do you remember, what do we press to figure out or calculate where the root is?
Is that like second calc?
Okay, second calc, yep.
Value?
No, not value. We usually don't use value much at all. I don't know if I've ever used value. I think you could. I'm not even sure what it does exactly.
No.
So intersect is if we have two different lines and we're trying to see where they cross.
I remember using maximum.
We did use maximum or minimum. We did use one of those actually when we did the projectile motion I think that was last week. We're not trying to find a maximum or a minimum.
0.
Yeah, we're trying to find a 0. We're calculating where this graph crosses the x-axis. So we have to pick a point that we know is to the left. Then we have to pick a point to the right. And then we hit enter. And as we kind of thought, it's not exactly negative 1, it's negative 1.09. That's the approximate answer. Now you'd have to do that for every root, but since there's only one, we only have to do it one time. Any questions on that? Okay, so that's finding roots. So this one is a transformation where they're giving you something to start with, y equals x squared, and they want you to do some steps to it to move it or stretch it. When we do transformations, what's the first transformation that we always start with? We don't always have every transformation, but what would be the first one we would start with? Translated which way? So the up and the down, that vertical shifts, that's always the last thing you do. So that's going to come at the end. So we'll save that for the end, for the last part. So which one do you think we handle first? The vertical stretch or the translate 3 units left?
Translate?
Yes, we do the translation left and right in this problem first. If you want to translate a parabola 3 units left, do you remember how you do that?
It would be the x value.
Okay, so you've got to do something to the x value. What would the equation look like if it was just a translation 3 units left and it didn't have anything else?
X minus 3.
Okay, so x
Squared.
Can you say what you said first again?
X minus 3.
X minus 3. So if you do, okay, you tell me how to write it. So x and then what? Minus?
Would be squared minus 4.
Like this?
Yeah.
And then what?
Minus.
Like that? So that's a vertical shift. That's going to move it down 3 units. So we do want to move it vertically, but adding or subtracting a number on the outside of the x squared is going to move it up or down. We have to add or subtract a number inside the x squared. Do you think we would add to move it to the left or subtract? And remember, this is horizontal.
So would you
For horizontal, yes, you have to do the opposite. So if you want to move it to the left, you have to add. So the first part would be x plus 3 squared. That's a shift 3 units to the left. Now the next thing we do is the vertical stretch by a factor of 6. If you want to stretch something vertically 6 times as much, how would you do that in that equation? First, think of what operation would you use. So we used adding and subtracting. We wanted to shift it. You multiply, and do you remember where you multiply to do a vertical stretch? Say it again. Well, it's going to be on the right-hand side. So yeah, we're going to leave the y. It's always y equals, and we have to do something on the right. Multiply the x plus 3 squared by what? 6. So when you want to do a vertical stretch, you multiply in front by the number you want to stretch by. In this case, it would be 6. So now that takes care of these two. How about the translate 5 units up?
Is it on the right side?
Yeah, everything's on the right side.
On the end, would you add?
Yep, you put plus 5 on the end, and that will shift it 5 units up. So that's how you, so you could have a question that either gives you some transformations and asks you to write the equation, or gives you an equation like that and says, write down the steps or write down the transformations. But there'll be a question like that on the test. Okay. Any question on that one? Okay, so we got that one. So the rectangle problem, some different things you need to know. You definitely need the area of a rectangle. And what's the formula for the area of a rectangle? Yeah, the base times height or length times width, however you want to say that. And then another part of this is going to be knowing how to write a phrase from words to math. So if I said to you the width, let's just say the width is 7 more than the length. How would you translate a sentence like that into more of like an equation? The width is 7 more than the length.
W equals 7 plus, 7 plus 7.
Yeah, W equals 7 plus L. Now, if we draw that, you picked a variable, well, actually, I don't want to say anything. How would you label the top side in that diagram?
L.
L, and the bottom side?
L.
L. And how would you label the two short sides in terms of the letter you just used?
7 plus L.
Yeah, 7 plus L and 7 plus L. Now, if I asked you to find the area of that rectangle, what would you write down in those parentheses to find the area of the rectangle?
Do you just do it L times 7 plus L?
Yeah, so L times 7 plus L. And you could FOIL that out and see what you get. But that's, if you understand that, then that's a big part of the rectangle problem. Yeah. Being able to translate a sentence into an equation and knowing what the formula for the area of a rectangle is, you should be okay. And then you'll end up with an equation eventually that you're going to have to solve. In this case, if you were to distribute this out, what kind of equation would you end up with? No, it wouldn't be linear. It wouldn't be linear. Because when you distribute, what are you going to get?
L squared plus 7.
L squared plus 7L. When you have something squared, that makes it what kind of equation? Quadratic.
Oh.
So when you have something to the second power, that's a quadratic. So you do have to be familiar with how to solve quadratics, whether you know how to factor, quadratic formula, or complete the square. I think we covered all of those this week. We didn't do a lot of factoring, but I know we did completing the square, and that includes some factoring.
So what was it that we should know? Quadratic formula?
So to solve a quadratic, yeah, either the quadratic formula, completing the square, or factoring. Any one of those three methods can be used. Factoring can really only be used if the numbers come out nice. If not, I usually go to quadratic formula.